This is video 10.4, Laws of Exponents. The goal here is to be able to use the law of exponents to simplify expressions. So you've learned about the law of exponents, and there are just a bunch of rules that we have to learn to follow. So let's take a look at some of the first rules here. So this first rule is when we're multiplying two things with the same base. So by base, I mean the x. It's got the same bottom, so to speak. And they are both to a certain power. So when we simplify these, it's as simple as adding the two exponents, because we think of it as we have a certain number of x's here, and we're multiplying by more x's. So altogether, we have a total of a plus b x's being multiplied. So I could write them out just to prove this to you, but the x to the third, remember, that means take x and times it by itself 3 times. That's what x to the third is. X to the fourth means take x and multiply it 4 times. So this is what I have. I have a problem with, look at how many x's. I have 7 x's. So this equals x to the 7th. And all we had to do was add the exponents. So when the numbers get too big for you to write this out, you simply add the exponents. So this next one, I don't want to waste my time writing out all of these 2's, but I see that there are 7 2's here, and there are 4 2's being multiplied here. So altogether, we have a lot of 2's. We have 11 2's being multiplied. So this is 2 to the 11th. And that is simplified because I've written with less numbers and symbols. So let's take a look at the next law. That's the law of multiplying exponents. Now we have what happens when we're dividing. So remember, this fraction bar really means dividing. We're dividing two exponents. Well, now the rule is to subtract. Okay, here's why. Let's take a look at what we have with 2 to the 4th and 2 to the 7th. We have 4 2's on top, and on bottom we have 7. Holy cow, we got 7 2's on the bottom. Let's get this out of the way. 7 2's on the bottom. So remember your big ones that we've talked about a lot this year. We have a lot of ones that can be created here. And look at what we have left. We have 3 2's. Hey, that's just 4 minus 7. 3 2's, and where are they? They're in the bottom. So we would really write this as 1 over 2 to the third. So we subtract the exponents to figure out how many are left over. But it's important that we write them in the bottom because that's where there were more exponents to begin with. Remember, there were 7 in the bottom? So there are 3 extra 2's in the bottom that don't create 1's. So we subtract to find how many extra 2's there are, and then we write them in the right spot, and they're in the bottom because that's where there were more. The other thing to remember is these 1's that are created, that's how I know this is a 1 on top and not a 0, because it's not, there is nothing up there, but remember what's up there is actually all of these 1's that we created with the 2's that canceled. So x to the 10th divided by x to the 4th. Remember, we can write that division as x to the 10th over x to the 4th. Remember, that means that the 4 x's on the bottom will cancel with 4 x's on the top, leaving 6 left over. So there'll be 6 extra x's on the top. That's just 10 minus 4 equals 6. So my answer is x to the 6th. Since they're on the top, I just write it exactly like that. I don't need to write a 1 underneath, but there is a 1 down there because these actually canceled on the bottom to make a 1. And 6 left on the top. So that's your rule of division. So these are the 2 simplified answers for the examples here. The final law of exponent is when we're taking a power of x something and we're taking it to another power. I'm going to throw another example in here just to show you. For instance, if we have 2 squared to the 3rd power, that's what this problem it looks like. The instructions say that I should do a times b according to this law. Let's take a look at why. Remember, 2 to the 3rd power means I'm going to write this 3 times. So I'm multiplying the inside by itself 3 times. 1, 2, 3. So in the end, look at how many 2's we have. We have 2 right here, 2 right here, and 2 right here. So altogether we have 6 2's. And that's simply 2 times 3 equals 6. So that's how I know my answer is 2 to the 6th power. So this is the reason why, and sometimes writing things out the long way will help you see why. So x to the 4th to the 3rd power, this example here, will just be x to the 12th. Because remember, I would write x to the 4th 3 times, and altogether I'd have 4, 8, 12 x's being multiplied. And that's why my answer is x to the 12th. Let's take a look at the next example. 2x to the 3rd to the 4th power. A couple of common mistakes that students make is they don't understand where that 3rd power is. The 3rd power is only on x. This really says 2 times x to the 3rd. X is to the 3rd, not the 2. And then we're doing that to the 4th power. So that means that I'm going to have 4 of these insides being multiplied. So in looking at that, I'm going to have 2x to the 3rd times itself, times itself, times itself. Well, this is getting old. I'm tired of writing these things out. So if I understand my law correctly, this says I'm going to multiply the exponents. So that means I can see what that means for the x. It looks like I'll have 12 x's again, x to the 12th. And look at what happened when I wrote it out. Do you see the 12 x's? But I also have how many 2's? I have 4 2's. 1, 2, 3, 4. So I'm going to have 2 to the 4th. Now the good news is I actually know what 2 to the 4th is. I could do 2 times 2 times 2 times 2, and I would get, let's see, 2 times 2 is 4, times 2 times 2, I'm going to get 16. So this is even more simplified if I write 16x to the 12th. There's your answer for the second example. So if you want, you can write these out like I'm showing you to do here, because then you'll always get the answer right. But the rule is really nice to know because it makes things a lot faster. But if you forget the rule, you can multiply it out because exponents are just repeated multiplication. Just write it all out, find your ones, like we did in this second example here. So now we have this thing, this negative exponent that you just learned about. So this negative exponent, how do we work with that? So when we have a negative exponent, here's the rule with negative exponents that was established to describe other quantities. So a negative exponent simply means the reciprocal of the positive exponent. And of course it works the other direction as well. If it's negative in the bottom, then we flip it up to the top and it becomes positive. So it's as simple as that. It's just knowing that negative means it goes into the denominator or it flips up into the numerator. So for this first example, I see this negative exponent. In math, we don't usually like to write things with negative exponents, but sometimes the problem requires us to. So this negative exponent, it really can get flipped up to the top. And this answer can be 2x to the 5th y squared. 2x to the 5th y squared. So that's my answer. That's my simplified answer. This is written more simply. It's not have a fraction, and there's no negative exponents. Negative exponents are often, we want to get rid of them. So in this case, we need to get rid of the x to the negative 3. So 3y squared, that's all positive exponents. That's going to be on top. But the x to the 3rd is going to flip down to the bottom and become positive. This is a simplified way to write this because it's more proper. So this is the proper way to write this problem. So negative exponents, you flip them to the top or bottom depending on where they are. They flip under. It's the reciprocal of the original value. The next thing, this one's pretty easy. Every single number to the 0 power will equal 1. Well, everything except for 0, that is. Okay, but we're assuming these x's are not 0. So any number besides 0 to the 0 power will equal 1. So it doesn't matter if there's something like 2x in there. This is as simple as 1. 5 to the 0 is 1. These are all equal to 1. Okay, that's a simple one. That's going to help you make things easy and simplify and get rid of them pretty quickly. So let's give these more complex examples a shot. 2xy to the third plus times 5x squared y to the fourth. Holy cow, we got lots of stuff going on. Well, the first thing that I'm going to use is the rule that you can multiply in any order. This is all just multiplication, and I'm going to rearrange things. I'm going to put the numbers in front. Then I'm going to take the x's and put those together. And then I'm going to take the y's and put those together. This is called the commutative property of math, of multiplication, excuse me. I can organize this in any order. Now I can simplify, because I know that 2 times 5 is 10. I can do that. The next thing I know is that I look at how many x's I have. It looks like I'm multiplying 3 x's, because this is 1x. Even though we don't write the 1, it is x to the first power. So altogether there are 3 x's here. So that means I have x to the third power. I've added the exponents and used the second law, the first law that you learned about. And the final one, the y's. How many y's do I have? I have 7 y's being multiplied. So y to the 7th. So my simplified answer is 10x to the third, y to the 7th. There's my solution. I've simplified and written this in a more simple way. How about this one? Now I have negative exponents. Again, when we ask to simplify, we're actually asking to get rid of negative exponents, no matter where they are. So the 3 is okay. It's going to stay on top. But this x to the negative fourth is going to flip down to the bottom because it's equal to 1 over x to the fourth. So now that's going to be on the bottom. This y squared, it's fine. It's on top. It's positive, so it's going to stay on top. And last but not least, the z to the negative 3, that's the same as 1 over z to the third. So I'm going to write it down on the bottom to make it a positive exponent. So I have simplified this rational expression. It is 3y squared over x to the fourth z to the third. Positive exponents are a more simple way to write things. So we're going to simplify by getting rid of the negatives. So now what if we have this big fraction? So what we're looking for is big ones. So hopefully you see what this simplifies to. Nice thing is everything's written in a nice organized way already. 14 over 7 is just 2 on top. Now we look at our x's. Let's see, I have 2 on top and 5 on bottom. So that means if I wrote it out, I have 2 on top and 5 on bottom. Do you see the ones? There are 2 ones, and there'll be 3 x's left on the bottom. That's going to turn into x to the third, because that's easier, but it's on the bottom. So we've figured out the difference between 5 and 2, and we put it in the bottom because that's where the extras are. For the y's, the extras are in the top. We have 12 on top and 7 on bottom. So there's going to be extras on top, and let's see, 12 minus 7 is 5. So that means this is going to simplify to y to the 5th. So y to the 5th is on top, because there are 5 extra y's on top. So there is my simplified expression, 2y to the 5th over x to the 3rd. So when you're simplifying rational expressions and exponential expressions, using these laws is helpful, but writing it out can also be helpful. So if you forget them on a test a week from now and you've just learned them but you know that they're there, write things out the long way and you'll see the ones that are created, or you'll see how many y's or x's there are to help you simplify these expressions. Be sure to ask your teacher if you have questions on any of these. Some of your problems will get harder, so make sure that you ask for questions and use the answers on the back of your sheet to help you see if you're right or not.